Okay, so what is kinematics? Well, as far as you know.
Well, I don't know exactly what it is, but I sort of have an idea of how to solve the question.
Okay, so let's talk about first what it is. I'll write it over here. So, kinematics. Okay, so kinematics is basically the study of the motion of objects without regard to what causes the motion in the first place. Okay? So all you care about is how the object is moving. That's it. Right? Because then there's other studies that involve the forces dealing with the object's motion, and that's when you get into like Newton's laws and that kind of stuff, right? But we're not there yet. We just care about the motion of the objects, how they move. And let me just write that. Kinematics is the study of the motion of objects without regard to the forces which cause the motion. Okay, so tell me, what formulas did you learn in studying kinematics so far?
We have V equals V naught plus AT. We
Okay.
have S equals S naught plus V naught.
Okay, so
Plus 1/2 A.
hold on a
Yeah,
second.
we good.
So we have V is equal to V naught plus what?
V naught plus A.
Exactly. AT, which is acceleration times time, right?
Yeah.
And then what
And then
else?
we have X equals S naught plus V naught T
Mm-hmm.
plus
Mm-hmm.
1/2 A T squared.
Exactly. And this is the distance equation, okay?
Okay.
Or you can say the displacement equation. Mm-hmm.
Okay. And then we have T squared equals V naught squared plus open parentheses X minus X naught.
Exactly. So this is just a variation uh, of the V equation using the two previous equation, right? So this equation here comes from these two.
Okay.
Okay. Okay. What else?
And then the last one we have X equals X naught plus 1/2 open parentheses V naught plus T.
Exactly. Okay. So the thing is, all these equations I derive it on my website. If you check the step-by-step descriptions of the kinematic equations, you'll see how you can manipulate these two equations, this one and this one, to get these two. So we're going to call these the independent equations. We'll say um, this to this, we'll call it independent equations. And then here to here, we'll call them the dependent equations. Why? Because they depend on the independent equations. So the dependent equations. Right, they derive from the independent ones. So what is this telling us? Well, the first equation, I'll label it equation number 1. That's just the equation for the final velocity of an object. Okay? That's the equation for the final velocity of an object. Equation number 2, we'll call it the position equation, right? We'll call it the position equation because it tells you the position along the x-axis that the object or particle is centered on, right? We're not dealing with three-dimensional or two-dimensional motion here. We're dealing with only one-dimensional motion. So I guess you can say this is one-dimensional kinematics because we're only focused on the x-axis, right? So in essence, what we're saying is if we have just an x-axis, let me use black here. If we have just an x-axis here, and suppose this was the origin O, suppose this was the origin O, and the object or the particle started at a position x naught along the x-axis, then equation number 2 describes the position along the x-axis after a certain time t, okay? So maybe t seconds later, the position of the object is at position x, right? Okay, so how well do you think you are with kinematics? How comfortable do you feel with it? Oh yeah?
But sometimes I get confused.
Oh, okay. All right, let's take a look at the worksheet that you have then, and we'll try to work on some problems. If a basketball player can jump straight up to a height of 70 centimeters, what is his initial speed just after he leaves the ground? How long is he in the air? Right, so what kind of motion is this? Is this two-dimensional or one-dimensional? Right, so it's one-dimensional. Let's see here. It's one-dimensional motion. And what's the appropriate axis to use? X-axis or y-axis?
The y-axis.
Yeah, because he's jumping upwards, right? So you have to use the vertical axis. So we're going to be using the same equations, except wherever we see x, we replace it with y, right?
Okay.
Right, so right now we're looking for initial speed. What's the symbol for initial speed? That's acceleration. Right, acceleration is A. What's the symbol for initial speed? Let's go back to the whiteboard because we didn't define some of these symbols, right? So let's define them so that we're familiar with them. So V we'll say is final velocity, or you can say final speed. V0 is the initial velocity, right? What's x? Yeah, or you could say the position, right? X is the position. And what is, or let me be more specific. Let me say final position, right? Final position. And what is x0?
X0 is where they start.
Initial position, right?
Yeah.
Okay. Now, what are we missing? What's A?
A is acceleration.
Okay. Acceleration. And then what's t?
T is time.
Okay, so that's time. Okay, so now we have all of the variables, right? We know what they represent. Now, if we go back to the problem asks us to find the initial speed, right? Just after he leaves the ground. So what symbol are we looking for?
We're looking for V naught.
Exactly, we're trying to solve for V naught. So V naught is our goal. So what information are we given about the basketball player?
We're given the height that he jumped.
Exactly, we're giving the height, which is what?
The height would be the final velocity.
No, the height. The height.
Oh, the position.
So you're given the final position, right? So we're given x is equal to 70 centimeters. Oh, I'm sorry, we're using y. So we're using y. So y is equal to 70 centimeters. What else are we given?
We're given.
Are we given the initial position? Y0?
Yeah.
Exactly, we're given
Yeah,
y
we're
naught.
0.
So y naught is going to be 0, right?
And don't we have the velocity too? Because since he's jumping, he's like working the ground.
No, we don't have the velocity. That's what we're looking for. Well, we do have the initial velocity, right? I'm sorry, not the initial. We do have the final velocity, right?
Final. Yeah.
What's the final velocity going to be?
Should be 9.8.
No, you're thinking acceleration, right? Acceleration A is going to be 9.8, right?
Okay.
So that's going to be meters per second squared. And keep in mind, since he's jumping up, which direction is he accelerating towards?
Like he's going up, so wouldn't that make it a negative?
Negative, right? Because the acceleration is working against him, right? Gravity is pointing
Yeah.
downwards, so that means the acceleration, in fact, we can write it as g for gravity. So we could say a is equal to negative 9.8 meters per second squared, right? Or we can say is equal to negative g, because g is the 9.8 meters per second squared. Okay? So we're given all of this. We're also given that, remember, he jumps up a maximum height of 70 centimeters, which means that once he reaches that 70 centimeter height, he stops momentarily before falling back down, right? Does that make sense? He goes up, and then he stops, and then comes down.
Yeah.
Right, which means that the final velocity, v, is going to be equal to what?
Zero.
Exactly, 0. So these are the pieces of information that we have to make use of. Okay? First piece of information is that his final position or final height is going to be 70 centimeters. Second piece of information is that he starts from y equals 0. Okay? Third piece of information is that the acceleration is the acceleration due to gravity, which is negative g, which is negative 9.8 meters per second squared. So that's the third piece. Fourth piece of information is its final velocity is going to be 0, right?
Okay.
All right. And we're looking to find V0. All right, we got to keep that in mind. Okay. So we go to these equations, right? Now remember, we're not giving time, right? So we have no time to work with. We're not giving anything about time. We don't know how long it takes for him to jump that high. So we go to these equations and we look for which one of these equations involves all of these but no time, so that we don't have to worry about knowing what time is.
So would that be the third equation?
Exactly. So we use, I'll say we use equation 3. Okay? Okay, so try to solve for V0 using equation 3. Okay, so you got 37 meters. So we have V squared is equal to V naught squared plus 2 times A times X minus X0, correct? If we go ahead and substitute the values, we know V is going to be equal to 0, right? So we have 0 is equal to V naught squared. And then A is just negative G. So we have minus 2G. Now, I put X. This should be Y. Y minus Y0. Right, so negative 2G times, and we know that Y is going to be 70 centimeters. So I'll just put Y, and Y0 is 0. Okay? So this tells me that V0 squared is equal to 2 times G times Y, which means that V0 is equal to the square root of 2 times G times Y. Okay, so if we plug in the numbers, we have 2 times 9.8 and times 70 centimeters. Now, hold on just a second. You have to keep in mind that Y is in terms of centimeters, right? So you have to convert it to meters.
Okay.
So that means that Y equals 70 centimeters is equal to 0.7 meters. Okay, so if you do all that correctly, you should get V0 equals 3.7 meters per second.
How'd you get 3.7?
Because I wrote 9.8 for G and 0.7 for Y, because Y is 70 centimeters. That's only 0.7 meters. All right, remember the unit conversion.
Then you get like what I got. I got negative 13.72.
Negative
When
13.72.
I put when I put 2 times 0.7 times negative 9.8.
No, 9.8, not negative 9.8. Remember, over here, let's go back over here, right? You see my cursor? Right? We replaced all the values. We substituted everything. When we got to A, we replaced it with a negative G, right? A equals negative 9.8, which is equal to negative G.
Yeah.
So Now you have 0 equals v0 squared negative 2gy, because the a became a negative g.
Okay.
Right? Then when you solve for v0 squared, you get v0 squared is 2g times y.
2g times y.
And then you take the square root. v0 equals square root of 2gy. G is the number g is just 9.8. It's not negative.
Okay.
Okay?
So then you get 3.7.
Exactly, right?
Can I just convert it at the end?
No, you can't. You have to convert it before doing the calculation. Otherwise, you're going to have mixed units. You're going to have meters times centimeters, It doesn't work like that.
Okay.
You have to convert it before doing the calculation to avoid any, confusion or wrong answers.
Okay.
Okay? So you always make sure. That's why for me, whenever I get these problems, the first thing I do, once I figure out what variable is what number, I always convert everything to the standard units. Meters,
Okay.
seconds, and what else? Kilograms, right? Once you finish with those conversions, then you go ahead and solve for the problem and you plug in the numbers.
Okay.
Cool?
Can you explain to me why, can you explain to me why A is equal to negative G and not just G?
Because A, remember, if you look at the formula, right? All these formulas were derived assuming A was positive, right?
Okay.
Right, using plus 2A, all that stuff, right? But when you're working with these problems, remember, these are general formulas, right? It's possible for A to be
Okay.
positive or negative. So in the case where you're dealing with gravity, and gravity is acting against your direction of motion, like the basketball player, right? He's jumping upwards, but gravity is acting downwards. So gravity is acting in the negative direction of the basketball player. So your A has to be minus G. The value of G is equal to 9.8, right?
All right.
But you put that extra negative sign to say it's acting opposite the direction of the basketball player,
Okay.
right? Once you do that, you get v0 squared plus 2a times all of this is equal to v0 squared, and then the a becomes a minus the g, right? So that's why you have to put minus g.
Okay.
Okay, you don't put plus g. That'll be incorrect because then you're saying the basketball player is jumping up, but he's accelerating up, which means he's going even faster and faster.
Oh, okay.
Yeah.
So then let's use V naught in the first equation. Wait, no, sorry. Yeah, the first equation to get T.
So you're using
So
wait, what are you trying to get? The time?
T.
Okay, how long is he in the air? Exactly. So now that you have V naught, you can go into the first equation and just solve for T. Okay? And for that, uh, move this up a little bit. We find that we have V is 0 already, so now we have 0 is equal to V naught minus G. Always remember that A becomes a minus G times T, which means that V naught is equal to G times T. T is equal to V naught divided by G. Okay, yes, so you do this divided by 9.8. You should get 0.38, right?
Yeah, that's what I
Okay,
got.
so that means, let me write that here. You get V naught is equal to, V naught was 3.7, right?
It was 3.77, so I rounded it
Yeah.
to make it equal.
And then for T, we just get 0.38, 0.38. Okay, so we good with everything?
Yep.
All right, man. So hopefully this was helpful to you.